Hello everyone, welcome back. These are the starters 102 problems that were not in Division 1, and I will just be running through these. You get the idea. I've done a few of these before. So we have our first problem. This was the very first problem, sports section. We have random page number X. We have to determine if it's a page in the sports section, and the last 3 pages are always in the sports section. So there's always 10 pages, so that means the last 3 pages have to be 8, 9, and 10. So we can just do something like print yes if read int, so we just read the integer, is at least 8, because it will be 8, 9, or 10. Otherwise, no. Just run here, make sure we have no bugs. Successfully executed. We can also try on 8 as well. And submit. Alright, that looks pretty good. And we can go to the next problem, which will be selling insurance. We got a new job as an insurance agent. Each insurance costs X dollars. There's a 20% commission. How many insurances do you need to sell to earn at least 100? Keyword is at least 100 here. So first let's read our values. Now what we notice here is that every insurance is always a positive value. We're not going to have like 0 here, so no division by 0 errors are concerned. And if we take a 20% commission on selling each insurance, then you can think of it like we have to sell $500 worth of insurance, because 20% of 500 is 100. So what we just need to do is find the minimum number of like insurances that their total cost is 500. So in this case, what we can pretty much do is 500 divided by n. We can even do a quick answer equals like this. Now this is 4 division, so if we have 4 division, then let's say if the insurance cost $80 in the second case, then this would end up being 6, but we'd have that remaining $20. So we'd have to add 1 to this. But there's one more thing, which is that if 500 mod n is not equal to 0, if it was equal to 0, we have an exact case, and we don't need to do this plus 1. And then print answer. There is another way you can do this. There's one more trick as well, just in general. When you have to do ceiling division, you can also replicate this by doing n-1 here. Just adding n-1 to your base total. And if you think about it, it will make sense, because if you have an exact value, then that n-1 isn't going to actually increase it. Otherwise, you're going to have at least 1 remainder, and then you'll get that plus 1 case going. Just cue the submission, and there we go. We have our next correct solution. So we go to Chef and Stocks. We have the stock market, there's a favorite stock, and consecutive days. So what's the maximum profit if you skip trading for 1 day? Okay, so you traded it for n consecutive days. You have profit on the ith day, and then there's negatives. So let's look at our input, and we can just confirm that what I'm thinking is correct. So we just read the input and then read the array. And already you might be starting to see how this might work. if you skip trading for exactly 1 day, so even if you don't want to skip, you still need to skip 1. And that's our biggest clue. So if we take the sum here and just ignore the lowest value, we get 4. We take the sum here, ignore the lowest value, you get 10, and then so on. This is 10, and then this would be minus 10. So what we can then do is, if n equals 1, print 0, because we'll just skip that 1 day. Else ar.sort print sum, and then starting from the second value, because the first value will always be in the lowest. It could work without this if statement, but it's just safe. It's probably safer here. This is just for visual demonstration. Alright, nice. So we got that problem as well. Very good. So that brings us to our final problem, array sum, and it's a bit of an interesting problem. Normally when I do these later recaps of the problems that weren't in Division 1, you usually don't expect a problem of this high complexity to be here, but we can give it our best shot and we'll see how it goes. So we have an integer n and k, n will be always even, and we have to generate a size n array. So the number of odd elements has to be the same as the number of even elements. The sum of all elements in the array is k. Okay then. So let's just make sure we are reading this correctly. Every value has to be between 1 and 100,000. Okay then. So this is a little bit trickier, but there's a few things that we can definitely confirm. We can confirm how many odd elements we have. So for this, actually this question, we probably want to bring out the old drawing board here. This will be pretty useful. So we're going to always have n over 2 odds and n over 2 evens. Now the thing is that you can add however many even values you want. No matter how many even values, 2 evens, 3 evens, 4 evens sort of thing, you always get an even sum there. Now with odds it's different. Like an odd number of odds adds up to an odd value, and an even number of odd values will add up to an even value. So there's our first clue. We have to first check if, given the number of odd values we have, if our sum is odd, then we have to then n over 2 has to be odd. Otherwise, n over 2 has to be even for an even sum. So let's do odd count n over 2. Or actually, we're gonna do this as a solve. nk, and the reason we want to do it like this is it just makes the if-else statement things easier. So if it's not equal to k over 2, so if k is even and our odd count is odd, or vice versa, it's impossible. And that should be about right. Now, what is the other problem that we could have is we could have our sum could be too high or too low. So let's do, so we can calculate the min sum and the max sum. Now, the minimum sum is every odd value is 1 and every even value is 2. We can't have 0 because of this first constraint. So that would be 1 times the number of odds, n over 2, and then evens 2, n over 2. So it's basically 3 times odd. Maximum sum is similarly calculated as 99999 and 100,000 for your odd and even values. So 199999 times odd. So if k is less than min sum or k is greater than max sum, also return -1 due to out of constraint errors. Otherwise, it has to be possible. Now, how do we want to do this? Let's see. There's actually a few ways we can do this. I think, yeah, let me think here a little bit. Okay, I think I see it. I think the easiest way you can do this is you just start with the maximum sum here. So let's just do a maximum array sum. So our array will be, let's start with the odd values first, times odd plus this, and these are your even values. Now this formatting may look a little bit weird, but this is just going to create an array of n over 2 values of 99999, and then n over 2 values of 100,000. And then our difference is just going to be max sum minus k. So then for I in range n, now the maximum amount that we can subtract from each value is 99998. And that's what we're going to try and keep doing until we run out of space. So if diff is greater than 99998, ARI minus equals this, and our difference is also this. Otherwise we can just subtract the remaining difference there, and we should be done. And now that I think of it, there's one more thing we have to do. Let's remove this print statement. So then we'll be doing our solves here. So we can still return -1, but we're going to print the answer in our function. And the reason for this is because we actually want to use a special form of printing here, where we just do print $AR to print each value space separated. Okay, now we're going to see if this works. Okay, it looks about right here. 1, 1, 2, 16, 1, 4, -1. And we can try submitting here. And that's pretty much it. That's the correct answer. So I hope you like this walkthrough, and I will see you all next week. Yeah, take care.